Every time you look at a modern vehicle, you're looking at a brilliant piece of engineering with a massive, heavy secret. For decades, the skeleton of your car has been a complex puzzle of over 70 individual pieces of stamped steel and aluminum. But in March 2026, a new titan emerged from the collaboration of Comau and Reis Robotics. This isn't just a bigger machine, it's a 9,000-ton monster designed to delete that complexity forever. The goal is simple but incredibly difficult. Replace those 70-plus welded parts with a single monolithic chassis. One shot, one part, and a total revolution in how we build the physical world. To understand why this is a big deal, you have to understand the nightmare of traditional assembly. Every weld is a potential failure point, every joint adds weight, and every robot in the line adds time and cost. By moving to a single casting, engineers can optimize the geometry of the metal in ways that were previously impossible. They can put strength exactly where it's needed and remove it where it isn't. This shift isn't just about saving money, it's about structural integrity. A single piece of metal is inherently stiffer and more predictable than a collection of parts held together by glue and heat. But building a machine that can cast an entire car frame is an engineering challenge of the highest order. You aren't just pouring metal into a mold, you are managing a violent physical event. The Comau and Reis system represents the pinnacle of this Giga-Casting philosophy. It's a machine that operates at the very edge of what material science allows. To make it work, they had to solve three impossible problems: heat, speed, and pressure. And the numbers behind these solutions are absolutely staggering. Think of the Giga-Press like a giant, high-precision injection needle. Instead of medicine, it's injecting a house-sized volume of liquid aluminum into a complex mold in less than 1/10 of a second. The scale here is hard to wrap your head around. The machine itself weighs more than a dozen Boeing 747s. It requires its own dedicated foundation, dug deep into the bedrock of the factory floor. This is the Giga in Giga-Press. It's not just a marketing term. It's a description of the sheer physical presence required to dominate the physics of molten metal. But why now? Why did it take until 2026 for Comau and Reis to deploy a system of this magnitude? The answer lies in the simulation technology that finally caught up to the hardware. We can now predict exactly how a 1290-degree liquid will behave as it screams through a mold at 20 miles per hour. If the metal cools too fast, the part fails. If it moves too slow, it won't fill the mold. The engineering behind this is absolutely brilliant, but it's also terrifyingly violent. To see what I mean, we need to live inside the shot, the moment the metal meets the machine. At the heart of the Giga-Press is the injection phase. It starts with aluminum heated to exactly 1,290 degrees Fahrenheit. At this temperature, the metal isn't just hot, it's a glowing, low-viscosity liquid ready to be unleashed. This molten metal is transferred into the shot sleeve, a massive horizontal cylinder. This is the barrel of the gun, and the bullet is 100 kilograms of liquid aluminum. The plunger then accelerates with incredible force. In a fraction of a second, it pushes that metal into the mold at speeds reaching 30 feet per second. That's faster than a major league fastball. Imagine trying to catch a liquid fastball with a steel glove. The kinetic energy involved is staggering. As the metal hits the walls of the mold, it generates a massive hydraulic shockwave. This isn't a gentle fill, it's a violent explosion of metal contained within a steel cage. The metal has to reach every corner of the chassis, some of which are only millimeters thick, before it begins to solidify. If the metal slows down, it freezes and creates a cold shut, a fatal flaw in the part. To prevent this, the Giga-Press uses vacuum pumps to suck the air out of the mold before the shot, removing all resistance. As the metal fills the mold, the temperature management becomes critical. The mold itself is laced with complex cooling channels, circulating oil or water to pull the heat out of the aluminum as fast as possible. This is a delicate dance. Cool it too fast and the metal won't fill the mold. Cool it too slow and you can't open the machine to take the part out, killing your production rate. In the Comau system, this cooling is monitored by thousands of sensors, adjusting the flow in real time to ensure every single chassis is identical to the last. But here is the most terrifying part of the physics, the clamping force. As that metal is injected at high speed, it tries to push the two halves of the mold apart with millions of pounds of force. If the machine doesn't hold them together, the molten aluminum would spray out of the seams like a supernova. This is why the Giga-Press is so massive. It has to provide 18 million pounds of clamping pressure. The engineering required to generate and sustain this force, without the machine itself snapping in half, is what separates the Giga-Press from every other machine on Earth. To achieve this, Comau and Reis used a unique hydraulic toggle system. It's a mechanical advantage masterpiece that multiplies the force of the cylinders to reach that 9,000-ton peak. Once the metal is injected and the pressure is held, the aluminum solidifies in seconds. The machine then pulls the halves apart, and a robot reaches in to grab the finished chassis. What just happened in those 90 seconds used to take hours of welding and hundreds of robots. It is a violent, beautiful, and incredibly efficient transformation of matter. The implications of this technology go far beyond just making cars faster. By moving to monolithic castings, we are fundamentally changing the physics of the vehicle itself. A one-piece chassis is significantly lighter than its welded predecessor. In the world of electric vehicles, weight is the enemy of range. Every pound saved by the Giga-Press is an extra mile on the road. And because there are no gaps or joints, the car is quieter. The NVH, noise, vibration, and harshness, is drastically reduced because there are no parts to rub or rattle against each other. But the Giga-Press also changes the factory. A traditional body shop is a forest of robots and conveyors. A Giga-Casting factory is sparse, clean, and incredibly fast. This allows for micro-factories, smaller production centers located closer to customers, reducing the massive carbon footprint of shipping cars across the globe. We are seeing the death of the mega-factory as we know it, replaced by a system that is more like a high-tech bakery than a traditional assembly line. There are still challenges, of course. If you crash a car with a monolithic chassis, is it repairable? Engineers are solving this by designing crumple zones that can be cut out and replaced. They are also developing new aluminum alloys that don't need heat treatment after casting. This saves even more energy and prevents the part from warping as it cools. This is the genius part, solving a hardware problem with chemistry and software. The Giga-Press is just the tip of an iceberg of innovation that touches every part of the supply chain. As we look toward the future, the Comau and Reis 9,000-ton system is just the beginning. 12,000-ton and even 15,000-ton presses are already on the drawing board. Eventually, we might cast the entire structural frame of a vehicle in just 2 or 3 massive shots. The car of the future won't be built. It will be printed in high-pressure steel and aluminum. This is a return to the simplicity of nature. Think of an exoskeleton, a single, unified structure that provides both protection and form. We are finally building machines the way biology builds life. The next time you see a modern EV glide silently past you, take a second to think about the violence that created it. Think about the 1,290-degree metal screaming into a mold at the speed of a fastball. Think about the 18 million pounds of pressure that held that metal in place, and the thousands of engineers who turned a chaotic explosion into a precision instrument. The Giga-Press isn't just a machine, it's a testament to what happens when we stop trying to manage complexity and start trying to delete it. And that is the true beauty of engineering.